Hey everyone, it's your boy Matt, or Three Clips, and today we're going to be making another tutorial video on magic spells. This is an episode, I think we're on like episode 6 or 7 of how to magic spells, so this is going to be a continuation of that. And but today we're going to be going over one of the tutorials that I've made and I spent a lot of time on. It's completely original by me. So I'm hoping that you guys will enjoy the tutorial. But it is actually called Absolute Basics Part 1 Spell Chaining. This guide is intended for those who are making their first custom spells, and apparently making our own spells is simple. Wait, what is as simple as chaining existing mechanic? Okay, I think I'm dumb, but that made my brain hurt. I'm just messing with you guys. Today we'll be doing a tutorial on EquationEffect. A lot of you guys have been asking in the Discord and everything, oh, how do I make EquationEffect? Oh, I want to be like Noxa or my name, all the talented spell users. Okay, everyone wants to be my name. Okay, no one wants to be Three Clips. Okay, what's wrong with my spells, huh? I make good spells too. But yeah, we're gonna be doing EquationEffect. So for those of you who do not know what the equation effect is an effect preset that is within the effectlib uh, directory. So with equation effect, you use the concept of parametric equations in order to create a curve of particles. So if you guys are still confused on what that is, I'll go over it more later on this video and give you a detailed indication of what equation effects are. Now, a couple things is the equation effect is very, I would say difficult, but it does require some math understanding, especially in trigonometry, or if you've already taken Calculus 3, you guys should already be familiar with the concept of parametric equations. But any sort of math or math knowledge on trigonometry, or even Calculus 3 would actually help you with the equation effect and understanding it. So let's go ahead and get into it here. We're going to first start by defining what a parametric equation is. So a parametric equation is literally a equation, an XYZ equation on a 3D plane. Now, most of you guys have done math on a 2D plane. So let me just pull up here Desmos because most of you guys do know what Desmos are. Desmos is just a graphing calculator. It's going to help you here. This right here is a 2D plane. So you have here the x-axis alongside the bottom horizontally, and then the y-axis over here vertically. Now, if I type in an equation here, say y equals x squared, it's going to draw a curve here illustrated by the xy plane. Now, what happens if we wanted to use a 3D plane instead? That leads us to over here to parametric equations. Now, with parametric equations, it doesn't go by the x term. Instead, it goes by the t term because the x term is actually a function of an equation. So what does this mean? It means that if I set this all to 1, and I did cos of t, let's hope this works. Okay, it did not work. So let's try this. T1, let's try this. There we go. I'm gonna make this a little bit more simple for you guys to see. Does that work? Yes, it does. Okay, let's try this. So t here and do 1 here. See if this works better. No, it does not. Let's see here. Let's try this t, and then let's do 1, and then t like that. It should work, yep. So this right here is pretty much the same exact equation that I've put into Desmos here. You can see the parabola curve goes upwards here. So this is literally the same thing. Now, let's say I want to put in another equation here. Put in cos of t. It's going to combine the equations of both the parabola curve, and if I move on to the look at the z-axis, I think this would be a better representation. If you zoom out far enough, you can see that it starts to make the cosine curve here. So in essence, what parametric equations are is an equation on each axis. And it combines them all together to make one complete curve, if that makes sort of sense. So you see right here, you can put an equation here, which was what we did with the cosine t. So that's why if you look at it from this angle here, it forms a cosine wave. But if you look at it from here, you see that it goes on to form a parabola all the way through. Now, what does that mean with the equation effect? That means that we can actually create our own curves using this concept here. So for example, if I combine the sine wave with the cosine wave, and I'll put this to 1. See if this works. Okay, that doesn't work. So this. If you look over here with the x-axis, or sorry, this should be the y-axis, yeah. With the y-axis, it makes the sine curve here. But we look at it from the z-axis, starts at 1 because your cosine will always start at 1 at the origin, and it makes a cosine curve here. So it combines both of them to create this sort of 3D curve per se, and you can actually put this into Magicspells here. The t I put on the x curve because if I put a 1 here, it's not going to know to go outwards or to not go outwards, but it's not going to move in the x-axis or in any direction. That's why it forms a circle here. If I put a t here, it's going to form that curve that we wanted here. Now there's other equations that you can do here. I could put a tan here, and it'll work the same exact way. You can see here the tan curve is a little bit weird, so that's why I never use the tan curve. But if you find a use for it, feel free to use it here. But this is more or less going to go over how exactly an equation effect works. So this is a normal spiral that you see here, and a lot of you guys have been asking about slashes and everything with the equation effect because you guys think it's all nice and cool, which I'm not gonna lie, sometimes it is a lot better to make your slashes in equation effects. However, it's not necessary at all. Notice here if I put a 1 here as opposed to a 2, you can see that when it's on 1, it forms right here, but at a 2, it forms over here. So this just gives it an offset. But if I put a t here as a variable, as long as t increases, this x line is going to increase as well. That's why this is dragged out that way. So hopefully that explanation made a little bit more sense and more clarification for you guys. All right, so let's go ahead and move on to making a little bit more complicated curves. So, not sure if you guys remember in trigonometry, but if you multiply a constant by the function, at least when it comes to sine, cosine, or tangent, it's going to make the curve a lot bigger. So I make this to 3. You can see that it's a lot wider on this axis. But notice here, it doesn't widen up on this axis here. If I go over here, you can see that it widens up like this. Again, I'm going to show you here. If I reduce it, shows a less amplitude on this curve here. But it doesn't show it on this angle here. And that's because we didn't do anything to the z function here. If I make this 3 times, just like I did with the y-axis, it's going to go ahead and produce a curve that has a higher amplitude for the z-axis as well. And as a result, if you multiply both by the same constants, 3 and 3, by both, it's going to increase the whole spiral in general. Now, I want this to be a perfect spiral, so what I'm going to do is I'm going to reduce the y a little bit. And let's do 1.5. I think 1.5 should be okay. And if you can see here, it's not so okay. I'm happy with this. I'm happy with this. This is a 1.5 times sine of t, and 3 times cosine of t. So this forms a pretty good spiral, I would say. Now, if you guys wanted to try, you can also multiply, raise this to a t if you guys like, and play around with all these equations here. You can see here, this is a little bit weird. So I'm going to link this grapher here in the description here. That way you guys can have a go at creating your own curves here. But once you're satisfied with the curve that you want in this whole graphing situation, you can actually go ahead and translate that to the equation effect. So that's what we're going to do here. This is your spell file that I've created to create our loop in. For my case here, in order to test this out and show you guys how the equation effect works in Minecraft, I'm going to use the instant dummy spell. If I can type, hold on. All right. And the instant dummy spell doesn't do anything. This is just for testing purposes. And I actually have a preset here for the equation effect because I do not want to type all that out again. So our normal effects here, like we discussed in previous sections, your position is going to be wherever your position is. In this case, I'm going to put it as the caster. You can play around with your other targeting positions if you'd like in your own spells, but for now, we want my effect or my equation effect to go ahead and spawn at the caster's position. Your effect here, I always put it to effectlibentity, and the difference between effectlibentity and effectlib is that effectlibentity, the particle will actually follow the either the position, either the caster or the target, wherever they go on each iteration. As opposed to the effect-lived effect, it will stay in that one place that the spell was initiated at, and it will just keep playing the iterations at that location. So depending on what you would like to use for your spell, effect lib entity or effect lib would actually suffice for yours. Now going on here, you're going to start the effect lib config section, and here you're going to specify the class. In this case here, it's going to be the equation effect. With the equation effect, you're going to have the particle, which indicates what particle is going to be visualized, I guess you could say, in the equation effect. In this case, it's going to be redstone. Why are we using redstone? Because it can be colored, and we like colors. So I'm going to move this over to one color here, and I'm going to move the S because I feel like that's going to be a little bit too confusing for other people. So I'm going to do white, and the hex color code for white is just 6Fs. The color will always go by hex color codes, but if you guys are having trouble finding your own color code, I'm also going to link this at the description below. And what this is I use this all the time. It's a color picker. So if you're having trouble finding or converting your binary codes to hex color codes, you can easily just use this color picker here. Choose, let's say you want this color, just copy this here, and then just paste it into your spell, and it works. Over here, if you see here, pure white is going to be 6Fs. So let's go ahead and do that. Particles, I'm going to put this at 2 for now. And the reason why I'm putting this at 2 for now is because I want to play around with it once I see it in MC. But for now, I want to get my exact curve onto Magicspells. That's exactly what we're going to do here. orientPitch, you can set this to true or to false. I always put this on true, and I hope that sometimes it would orient the pitch. Orient the pitch, but sometimes it doesn't work for some reason. And what orientPitch is that it just rotates the equation effect depending on where you're looking, up and down, left and right. I think the pitch is, if I'm not mistaken, it's up and down. Yaw, YAW is going to be left and right. Okay, so moving on, this is going to be your most important parts, your xEquation, yEquation, and zEquation. That's where we come into this graphic here. We're going to copy the xEquation here, and we are going to paste it in here. Same thing with the yEquation, and then same thing with the zEquation as well. Once we have here, I'm going to save here, and I'm going to do /ms reload. Let's make a time day for now. And then let's do ctest. Oh, look at that. Now, I don't know if you guys see it though, but this is way too fast. Way too fast. The particles are going all over the place. You can't really tell the shape. Yada, yada, yada. So, what we're going to do here is we're going to slow it down. In order to do that, we need to multiply the t, which stands for time. So every second t increases, and so on and so on. So that's what these functions are in the variable of. It's in variable. Its function is as of t. Is of t. Yeah, I think I worded that correctly. So what does that mean? It means that if we just multiply the t by 0.15, it's going to decrease the time and make it slower, which is what we want. So we're going to go ahead and do that for all of our t's. This is what it looks like after we multiply by 0.15. Make sure to put the parentheses around the 0.15, or else because of PEMDAS, it's going to multiply 0.15 with something else if you're not careful enough. So if I hit C test, you can see it's a lot. It's a lot slower. But it's not slow enough for me. I want to be able to go ahead and, sorry, I should do 0.8, 0.8. I want to go ahead and see this a lot slower. So I want to multiply it by 0.08 instead. And let's reload, C test, and there you go. Okay, this is a lot better. Now, notice here when I decrease the time, it stops right in front of me. If I move it back to 0.15, notice how the spiral forms a little bit more. Before, it stopped right in front of me. The particle stopped right in front of me. But now, it makes the full loop here. So why is that? Well, the equation effects spawns a particle for each value of t, or each second per se. Each millisecond, second, I don't know the specifics of it. So that means that if we sped up this equation effect, meaning I don't multiply it by a constant because I'm slowing it down by multiplying it by 0.15, then it will go ahead and form the spiral at a millisecond rate or whatever rate with particles spawning at different intervals. And because we're not slowing it down, the spiral gets a little bit longer. Or you see the spiral form a lot more or more complete. But if we slow it down here and we tell the curve that we don't want it to spawn that many particles in that interval, then you can see that more particles form in between particles, but it stops a lot sooner. So how do we fix this? Easy. We just change the iterations to, put this as 50. Iterations count how many particles you want it to spawn in the total. 0.50, and look at that. Let's see. So it spawns this perfect spiral just like that, which is exactly what we wanted here. And it goes in front of us too, which is great. That's what we wanted here. And if you look over here, this is what it looks like. So x-axis, you're facing forward. This is the person. And if you go like this, well, I think it's flipped over. Hold on. If I can get it. I don't think I can get it. Hold on. I don't know if I can get it. But yeah, it forms like that. If you want, you can play around with it. You can flip it upside down if you want. You could also put a negative here if you want to flip it as well, just like that. See? But I'm not going to play around with this. I'm kind of happy with this right now. But yeah. So that's how you put the equation on here. We're actually going to play with the particles too. I'm going to increase this to 20 and see what it does. And it increases the speed too. So not only can you increase the speed here, actually, what I think happened is, okay, so let's compare. We increase the speed using particles. And then we're also going to decrease the speed, increase the speed with just removing this constant here and see what the difference it makes. Okay, so you see here it's the same speed, however there's particles not forming in between the lines. So if you want to speed a particle up, all you got to do is just 20. Just change the particles, amount of particles, and it'll increase the speed as well. In this case here, I'm going to keep it as 2. And this is pretty normal. So notice here, because I changed orientPitch, it kind of goes wonky all over the place. If I look around and everything. But if I change orientPitch to false, it shouldn't anymore. And if it does, then I just embarrass myself. So, okay, it still does. That's why. No. Okay. Interesting. No. Okay. No. Yeah. Okay. So I turn this aside here. Okay. There we go. Okay. So it doesn't orient anymore. And that's because I changed it to effectlibentity. So notice here, if I put effectlib here, and then I walk away from it, it's going to continue in that same position. But if I put effectlibentity here, and I move, look what happens. It moves with me. Pretty cool, huh? Alrighty. Okay. But yeah, that's basically equation effects. The most complicated part really is just to create the curve for your slash. Really, you know, with my slash here, I mean, I could probably just cut it off at like 5. This will look like a really bad one, bad slash. But if you really want to do like a slash or anything, you can actually use this equation here. And then woo, 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 woo. Okay, hold on. That's a lot. Put 2. Oh, look, it's a slash. Whoa. Whoa. Whoa, I made a slash, guys. Okay, yeah. So it's really not that hard making a slash with equation effects. It just requires a little bit of math. That's it. But yeah, so that's how you guys would put an equation effect into Magicspells. If you guys have any suggestions at all or any questions, feel free to go to the Discord and the description, and someone will be able to help you. Um, and if you guys have any suggestions on what I should do next for the next video, please leave a comment, and then I'll go ahead and decide when I want to use the next tutorial. But other than that, it looks like we're all done here. I hope you guys learned a lot about equation effects. But as all, you guys be good, stay safe, bye.